Welcome to the video. In this video, we are going to talk about Spot VMs in GKE. Basically, we have already covered Spot VMs in Compute Engine in my previous videos. If you want to see that first, you can go and check out. I will drop a link in my description. And so I'm just covering an overview on this slide. After that, we will see more about for GKE, how it works in GKE. So Spot VMs are the VMs that use the Spot provisioning model. So this provisioning model lets you obtain resources at much lower prices compared to standard VMs. So if you are giving using resources and standard VMs, and you will get up to like 91% of discount sometimes. It will depends upon the requirement or how is that people are using your Spot VMs, or you can say demand and supply. All these things depend on the pricing. And Compute Engine can preempt Spot VMs at any time to reclaim resources and use Spot VMs to reduce cost for fault-tolerant workloads. So if your workloads are fault-tolerant, they can okay, like if VM goes shut down and you are okay with that, then you can use Spot VMs. And you have to remember Google can preempt Spot VMs. Preempt means it can stop your VM or terminate your VM or basically delete your VM also anytime. And it will not say this time I will preempt your VM. It can be anytime whenever Google wants their resources back, basically CPU and memory. Suppose Google has given you CPU and memory at a very lower rate because there is very low demand in the specific zone or region. But in the evening, demand goes up and clients want more CPU and memory. So what will happen? Google say, okay, I want my resources back, and they will just power off your VM, and you will get about 30 seconds to do all the saving and all that. And Spot VMs are available very low prices, as I've told you, up to 91% for many machine type like CPU and for GPU, TPU also, in local SSD also. During the preemption time, Compute Engine either stops or deletes your VM depending on your specific termination action for each Spot VM. So when the preemption will happen, Google or Compute Engine will stop. That is the default option, or even you can choose the delete your VM when the preemption happen. But this option is not available in GKE in that you don't have to configure this. It will taken care by automatically by GKE. But if you create a compute engine VM, it will you will find this option. And Spot VMs are not covered under SLA. You have to remember this. Now let's see how Spot VMs work in GKE. So when you create a cluster or a node pool with Spot VMs, GKE creates underlying compute engine Spot VMs that behave like a MIG, like managed instance group, in which it has, suppose you have mentioned I want three nodes in a node pool, so it will create a MIG in which you have a three node. Suppose Google reclaim, say I want my resource back for one VM, so it will be stopped or deleted, and your MIG will kept on trying to create that VM back until the capacity is back. So once capacity is there, it will recreate your VM. Until capacity is not there, it kept on trying. So this is how your Spot VMs work in GKE. Nodes that use Spot VM behave like standard GKE nodes, but with no guarantee or availability. So basically, it is kind of standard nodes only, like the same option, same CPU, same memory, but without of no guarantee. And when the resources used by Spot VMs are required to run standard VMs, Compute Engine terminates those Spot VMs to use the resources elsewhere. So as I already told you, so when Google required to run some standard VMs somewhere, or some client want those standard VMs and they don't have capacity as of now. So what they will do, they will terminate your Spot VMs so that those paid clients can use standard VMs. And after that, we have a termination flow. So you will get a termination notice to 30 seconds until shutdown. So by default, graceful shutdown, like node shutdown is enabled. So your non-system pods will get 15 seconds to terminate, and system critical pods also get 15 seconds to terminate, like kube DNS. And the kubelet updates pod status with field with terminated action. So if you run kubectl get pods, you will see this field with terminated region, and controllers reschedule replacement pods if workloads are managed. So if you have suppose controller like deployment controller or any controller, or you can say daemon controller, it will try to deploy your pods or another nodes if those nodes are available. If no nodes are available for Spot VMs or any standard nodes not available, so your pods will remain in pending state. So let's see how you can schedule workloads on Spot VM. So when you add Spot VMs to a cluster, GKE automatically labels them. So these are the two labels which GKE will put on your Spot VMs. And optionally, it can apply stains also. And you can control which pods run on these by using node selectors. You can use affinities, you can use toleration. So if you can use pod scheduling with node selector. So you can put this node selector, this basically this only label on your deployment specification or pod specification, in which you will say my pod will run on this node only on which this label is present. That is GKE spot equals to true. Even you can use pod scheduling with node affinity. This is more advanced of this node selector, and you can use node taints or toleration also. You can taint a node in which you can put a no schedule so that no pod can schedule on that specific node, and any toleration or taint which satisfy that condition can be scheduled on those nodes. I will show you how to do this taints and this all this. I will not cover affinity, toleration, and we have node spot VMs and node auto provisioning also. Basically, NAP dynamically creates or deletes node pools to fit your workload demands. So suppose if your workloads request spot VMs via node selector or node affinity. In node selector, you have defined I need this, I need a spot VM. So what will happen? NAP creates a spot VM node pool, and nodes in this node pool are automatically tainted. This option key cloudgoogle.com GK equal to spot equals to true and affect no schedule. So you have to tolerate this taint. Otherwise, if you don't tolerate, you will not able to schedule your pods. So pod must include this toleration to be scheduled there, and without the toleration, pods remain unschedulable. So we will see how to do this also, and how to like tolerate all these. And there are some best practices you can see, like spot VMs can be reclaimed at any time. So you must assume that zero availability guarantees, and workload must tolerate disruption because it can go down anytime. So your workload can go also down. And you must use mixed node pools. Always use at least one standard VM node pool for critical workloads and system component like kube DNS, kube proxy, all these. And deploy fault tolerant or batch workloads on spot pools. Okay, and we can use for that node selector or taints and affinities. And for GPU, you can use GPU spot node pools also, but you must also have at least one non-GPU standard VM node pool. So it is because it prevents system pods from being scheduled on expensive or unreliable GPU spot nodes. So otherwise your system pods will take all the space, not all the, but most of the space, and GPU is very expensive also. So you have to take care of that. And node names are usually stable, but internal and external IP address may change when spot VMs are recreated. So suppose something happens and your VM need to be recreated. It's a host maintenance event in which your VM need to be like migrated to a different host, but spot VM cannot be migrated. Google will stop and recreate it, and you will check the name are usually stable. It will not change the name, but internal and external IP address can be changed. So don't use node IP for system design. Always use like services and all that, and use taints on spot pools plus toleration only for workloads that can tolerate disruption that we have already discussed, and prevent critical ports like control plane add-ons from accidentally landing on spot nodes. Don't run any critical operation on spot nodes because it can go down anytime and it can harm your workloads or your applications. And all data on spot nodes is deleted when reclaimed. And local SSD attached to spot VMs are ephemeral and data does not persist. So if you are running saving any data on spot nodes, it will be deleted. And if you are using local SSD also, that is also not being saved possible. So these are some best practices, and like how spot VMs works in GCP or GKE. Let's go to console and let's see how to create a spot VM cluster. So I'm in my console. Let's go and create a cluster first. So in my standard cluster. So as of now, I will change it to zonal cluster because I don't want to waste money as of now, because it will create in regional, it will create so many in all the zones. So now let's go to our default pool in which you will find that option. Here, if you come down, you will find spot VMs. As you can see, the cost is $176 for a month. If I use a spot VMs, it will be up come down to $132. It will not 90%. It will rate is kept on changing depend on the usage. So what we can do, I will create a standard node pool first, then we'll create one more node pool in which we have a spot VMs. So because I don't want my system pods run on spot VMs, and in between the video my like VM goes down because of the capacity issue in Google, and they will stop my VMs and my cluster will go down also. So let us have a standard node pool first. So I will go here. I'm not doing much, just I will make it Standard persistent disk and 70 GB I want, and in the node pool I want only two nodes. That is enough for the video to test our these options. Everything looks good. Let's create a cluster now. So my cluster has been created. I'm in my inside my cluster, like I've logged into that cloud shell, and if I run kubectl get nodes, as of now I have a standard nodes. So if I try to run anything on that Spot VMs, it will not run. So what we can do now, as I've told you, that all the Spot VM has some specific labels. So what we can do, I do ls cd spot pods. If I go there and I do vi deploy.yaml, and one thing I want to fix it here. As of now, I want to remove this toleration. I'm not using this toleration as of now. I will use it later, but I'm going to use this node selector, and that is Google Cloud cloud.google.com gk spot equals to true. And let's run this command now. Now kubectl apply -f and deploy.yaml. And if we run kubectl get pods now, it will be in pending state because we have defined that we want to run these pods on a node on which there is a label called that is this GK spot equals to true. So this label is only present on the nodes which are basically Spot VMs. So what we can do now, let's go back and let's see what is the error it is giving. So let me describe this kubectl describe node, sorry, not node, it is a pod. So we can see there is error, 0 of 2 nodes are available, 2 nodes didn't match pod node affinity or selector, that's why it is not able to run. So now what we are going to do, we will add a new node pool. So if we go to nodes in our cluster, and we will find here create user manage node pool, and we will click on this, and after that we have to define a pool name. So let's give it Spot VMs, and here we can define a number of nodes. I am okay with two nodes, and here we will choose Spot VM. So basically we are going to create a Spot VMs node pool, and let's go to nodes and define machine configuration is okay, 2 GB and 2 CPU and 4 GB, all looks good. And let's click on create, and let's wait for it. Once it will be done, we will see whether our pods are scheduled on this node or not. So looks like our node pool has been created. Now let's see. Here we have node pool Spot VMs available for our. This is our node pool. It has two nodes, and if you go to our compute engine also, we will find these here also. So this is our GKE cluster Spot VM, and if you go inside that, at the last you will find all these options. Label you can find here, like uh, here you will find, see this one, cloud dot google.com GKE node pool. This one, not this one. This one like cloud.google.com GK spot equals to true. These are the labels which is already applied by Google only. And here you can see this is a Spot VM, max duration nothing preemptively is on VM termination it will stop, on host maintenance it will terminate the VM instance. So these are all the options present. Now what we can do, and we cannot edit this VM because it is managed by a instance group. Now let's go back here and let's see whether our pods are running or not. So if I run kubectl get pods, so we can see our both pods are now running. So basically it is running because of we have created a node pool of Spot VMs. But there is one more issue, like, but there is a possibility like other pods can also be scheduled on these nodes. So I will show you how that is possible. So if I go back here and I have one more file. So if I do cat second deployment dot, this is my one more deployment file available. So here we can see we have the option to run all these things. And here we are requesting 200 M of CPU, 7050 of all that. So let me create this deployment also, and let me say kubectl second dot yaml, and if I run kubectl get pods, we can see they are running fine as of now. And if I do cat hyphen o white, so it will show me the nodes on which it has been scheduled. So I can see these are being scheduled on even this second pool deployment. You can see second pool deployment has been scheduled on this GK cluster Spot VM. So suppose this is a very critical application and you don't want that this application must be scheduled on your Spot VMs. As we can see, our second pool deployment has been scheduled on this, as this VM can be go down anytime when Google say just give my capacity back. I want to give those resources to some other user. So for that you have some options. You can create a taint. So basically what will happen, when you create a taint, it will not allow any other pods to be scheduled on this until they will satisfy that toleration. So let's do that. So this is the command I'm going to use, kubectl taint nodes hyphen l labels. So it will check any node which have a label of this gk spot equals to true, and it will make a label on this like cloudgoogle.com gk spot equals to true no schedule. So let me run this. So it will create a taint. So if any your pod have this specific taint, then only it can schedule pods on that. So as of now, it will not delete any old pods. So if I run kubectl get pods, it will run fine. So you can see it is running fine. And first of all, I will try to show you. I will delete this pod, and you will see this new pod will not able to create because of this taint. So if I delete this kubectl delete pod, and I will just paste this name here, and pod has been deleted. Now if I run kubectl get pods, you will see this pod is in pending state. And see, this is in pending state and it cannot create because it is not able to run because of this no schedule one. So basically we are saying if any pod need to run on this specific nodes, both on this pod VM nodes, they must have this toleration available in their configuration or pod specifications. To do that, what we can do now, if I do if I go back to my spot pods and do cat deploy.yaml, you can see there is an option for that which we have previously commented out. So this is the toleration we can do. In that we will say the key is cloudgoogle.com gk spot. So this is the key cloudgoogle.com gk spot, and value operator equals to true and effect is no schedule. Once we enable this, then only we are able to schedule the pod. So we will go here vi deploy.yaml. So I have fixed it. Now redeploy this kubectl apply hyphen f deploy.yaml, and we can see kubectl get pods. We can see it has been completed. This one has been removed automatically because we have redeployed that our that YAML file, and this is now working fine. Two new pods are running, and you can see the age also. It is a rolling update kind of. And if we delete this one, as we know, like previously we see one pod is running. So let's see again which pod is that running here. And we can see this is one. This pod is still running on our Spot VM. Let's delete it, and after that, once we delete, it will go back to our standard VM nodes. So it has been deleted. Now if we run the same command again, we can see it is now the new container, or we can say pod has been created is in the our default pool, that is a standard one. So like this you can do many things with the Spot VMs. And as we know, like if there is a host maintenance event, what will happen, Google will in this basically in compute engine it will stop your VM, but here it will recreate your VM. It will try recreating until the capacity is there. So we will simulate a host maintenance event so that I can show you what will happen really. So now what I'm going to do, I am going to create a host maintenance event. It is a simulating or host maintenance event for this our Spot VM, this one Spot VM. So and we will see what will happen now. I will click on enter, and I have defined a zone also, a cluster our name also. It is running and it is done. I will do the same for another node also. So I will show you. Let me run this command also. So it will give 30 seconds to our node to, and after 30 seconds it will be deleted, or we can say recreated. We can see it is working and it is done. Now if I run kubectl get nodes, in some time our you can see both are the our Spot VMs are not ready. And basically if we are simulating, so this is what happens when something happens at the background. And if we run to kubectl get pods, your pods will be in pending state. So you can see this is in pending, this is in pending. These are all completed one you can ignore, but these are the new one. This is the pending one, this is the pending one. So now if you go back to our compute engine also and if refresh this page, you can see it is basically instance is running, but it will create a new instance. If you see the IP here, it will also change. As of now, it is 26 and 243. It will change in some time. And if you come to operations also, and if you go to operations, if you see the time 3:35 and click on this simulate maintenance event that has been run by me, admin. And after that, let's see what happened. And we can see it has recreated an instance. Google is doing this. It is repairing the, or we can say repair recreate instance. Reason instance eligible for repair instance should be running, but it is stopping because we have run the maintenance. After that, it will say instance preempt and recreate the instance. So that is done, I think. Now if we go back, okay, it is doing for the another VM also now. And let's go back here. And I think IP has been changed. I think it is 26 or I think 243, something like this. Yet it has been changed. Now if we go back to our VM here and let's run kubectl get pods, I think it will be running. So we can see it is now running. And if we run our kubectl get nodes also, we will see there will be new nodes. You can see it is has been created 30 seconds ago, and name will be same, but IP will be changed. So you have to make sure don't use IP anywhere for the Spot VM or any VM. Standard one also use services if you want a stable IP. And let's run again this command. I think another node will also be created. We can say this is also being created 14 seconds ago. And like this, you can do what we say. Uh, you can see how nodes like your Spot VMs works and how it affects your policies and your like applications. It can go down anytime, and this your application can also go down anytime. You have 30 seconds, so you can define a logic also. When you get a signal, you can define a logic app pods will save the work somewhere or do anything or run fault tolerant so that you can don't waste your time, all that. One more thing I want to show you. So let's go and delete this our where it is gone. Spot VM node pool. Now I want this node pool to be created by Google only. Once I defined and I want to run something, let's click on delete and just provide the name Spot VMs. Let's wait until it has been deleted, then we will move forward. Pool has been deleted. Now what we are going to do, I will want to show. If I do kubectl get pods, it will be in stuck state only as we have deleted the node pool. That's okay, I don't need this anymore. So I will delete the deployment also. Deploy. And I will delete this one also. I don't need this one as of now. And now let's go to our cluster and we will do snap, that is node auto provisioner. So we come here, you will find somewhere here in the automation part. Here it is node auto provisioning. Click on here and we will enable node auto provisioning. Here you have to define the maximum and minimum. So I want say it is for the total cluster, not for this our node pool. So I am okay with minimum 2 in my whole cluster and I want at least 10. Maximum 10 can go and same for the memory. So I'm not covering this auto provisioning. This is a different topic. I'm just sure what are the options we have and just click on save changes. So basically it is a node auto provisioner so that it can create node pools for us. So that we don't need to create any node pool by ourselves for Spot VMs or any VM. Take a time. Let's wait for a minute. So our cluster has been updated with the NAP. So if I run ls and do cat deploy.yaml. So in this we have file which we have already tried previously. Now this time what is there? It has the tolerations which we already seen like no schedule and true and equals to all that, and it has also have a node selector also. Now if we try to run this file, what will happen? Let's see kubectl apply -f deploy.yaml, and we can see it has been created. Now if we go to and check whether pods has been created or not, it will not because it is in pending state because we don't have any Spot VMs available. So we can see it is in pending state, but now what will happen? NAP, that is node auto provisioner, will automatically create a Spot VM node pool for us. So you can see it is already creating a node pool. It is NAB E2 high CPU, and if we go to our nodes also, and we can see it is creating a new node pool. And as of now, there is no nodes because it is creating. Once it has been created, we find some nodes also on which our application will start running. So you can see it as like increasing from 0 to 1 count, and it is kind of updating. Let's wait for a minute so that update will be completed. So our Spot VM has been created, and now let's go and check this VM. If I run kubectl, I'll get nodes first, and let's see. We can see there is a Spot VM node available. Now if I run ports, it will show as running only because we have a node now available to run our application. We can see it is running. So like this, you can use Spot VMs. You have there are multiple ways you can cause save your money also. And if you delete your these spots, what will happen after some time? Node auto provisioner will delete this node pool also because it is no more of in use. That's how you can configure NAP, but it is a separate topic I will cover later on. I'm just showing how it works. So that's all from this video. If you have any questions, any suggestions, just comment it down, or I will drop my email ID. If you have anything you want to connect, we can connect, and if you have any issue, just drop me an email. I will try to help you if I know how I can help. Thank you very much. Bye.